Have you ever wondered why your kitchen blender spins at lightning-fast speeds, so fast that you can barely see the blades? What's happening inside that seemingly simple appliance that allows it to pulverize ice, crush frozen fruit, and create silky smooth smoothies in seconds? In today's video we're going to break down a blender, yes, literally, and answer the question, why does it spin so fast? Stick around because you'll learn the hidden mechanics, the surprising physics, and even some tips for choosing the right blender for your needs. If you're into gadgets, kitchen tech, or just plain curious about how things work, you're in the right place. Why does a blender spin so fast? Stay till the end for pro tips. First, let's set the stage. A blender, the countertop kind, consists of a base housing the motor, a jar, glass or plastic, with blades at the bottom, a lid and sometimes a gasket, seal. When you hit on, the motor turns the shaft, that turns the blades, and you get that familiar whirlpool of whatever's in the jar. But we're not just talking about what it does. We want to dig into how and why it spins so fast. What enables that speed? What are the trade-offs? Let's go deeper. Inside the base you'll typically find an electric motor, many times a universal motor, one that can run on AC or DC, or other high-speed motor designed for the application. Why high speed? Because blending isn't just mixing, it's cutting, shearing, and circulating. The blades need to spin fast enough to create a vortex, pull ingredients down into the blades, and force circulation so that everything gets processed evenly. The speed allows the blender to overcome resistance from viscous ingredients, thick liquids, ice, fruits, and to reduce particle size quickly. In short, speed equals power and finesse. Another factor. The jar and blade geometry are designed so the high RPM, revolutions per minute, creates suction toward the center and draws ingredients toward the blades. That's part of what makes the blender efficient. In many models, you'll see speeds measured in thousands of RPMs. For instance, research shows high-performance blender motors may run at 10,000 revolutions per minute or more. Let's zoom into the jar. When the blades spin at high speed, they create a swirling motion, a vortex, in the liquid. The vortex pulls solids and liquids downward and then outward, mixing and cutting them. This swirling motion does a few important things. Shear forces. High speed creates shear. The blades moving rapidly past the material cause cutting and tearing. Circulation. Materials that would normally sit at the top get pulled down, ensuring everything comes into contact with the blades. Aeration, mixing. The speed also whips air into the mix, depending on the design, which helps with texture and consistency. Why does it matter that the blender spins so fast? Because if the blades moved slowly, you'd get pushing or stirring, not efficient mixing or pulverizing. The high-speed motion allows ingredients to be processed quickly and thoroughly, which is why your smoothie is smooth, not lumpy. So how do manufacturers control the speed? Many blenders offer multiple speed settings or even variable speed dials. What's going on under the hood? In some models, the motor has multi-tapped stator windings or field coil taps that change the torque-speed balance when you flip speed settings. In others, a triac or electronic speed controller reduces the voltage or modifies the waveform. Why is this important? Because when you're blending soft liquids, you may not need full power. When you're crushing ice, you do. So, the speed control allows the same machine to handle a variety of loads. Also, design factors matter. The motor's wattage power rating affects how much work it can do. The more demanding the job, ice, nuts, frozen fruit, the more power and the more robust the motor needs to be. And one more thing. The blender doesn't usually use a gearbox. To achieve high blade RPMs, it may rely on a high RPM motor directly driving the blades or via a simple coupler. Why can't a blender just spin slower and still do the job? There are trade-offs. If you spin too slowly, you may not generate the vortex required to pull ingredients into the blades, meaning the blender will just spin the contents around and leave chunks. Slower speed means less shear and less cutting action, right pointing arrow, less efficient blending. On the flip side, very high speeds create more stress on the motor, more heat, more wear, so designers have to balance speed versus durability versus cost. Some blender motors are only meant for short bursts at high speed, for example smoothie mode. If you run them continuously on high for long periods, the motor may overheat or fail. So the spin so fast answer is, it's not just about speed for speed's sake, it's about speed matched to design so that blending is efficient, fast and repeatable. If you're shopping for a blender, or just want to understand what makes a good one, here are important design engineering points. 1. Motor wattage, power rating. Higher wattage means more ability to handle tough ingredients, ice, frozen fruit, nuts. 2. Blade and jar design. The shape of the jar, number and angle of blades, and how they draw materials in, all affect how fast things are processed. 3. Speed variability. More speed settings or variable speed often mean better control and versatility, soft blending versus hard crushing. 4. Cooling, durability and build quality. A high RPM motor needs proper cooling and durable bearings, seals and couplers. Cheap motors may spin fast but die quickly. 5. User application match. If you just make smoothies of soft fruit, you don't need a beast of a motor. If you intend to crush ice or make nut butters, you want the robust gear. In short, high speed matters, but only when all the supporting design fits the job. Here are a couple of surprises for you. Some premium blenders claim blade speeds up to 20,000 revolutions per minute or more. Yes, that's 20,000 revolutions per minute. For one model, in fact. The jar shape matters. A tapered jar that funnels ingredients toward the blade helps create that vortex effect more efficiently. The term blender itself, it comes from the idea of blending, chopping, emulsifying, but under the hood it's the same basic physics of shearing and fluid motion. So next time you hear your blender word to life, think of it as a tiny engineering marvel. High RPM motor, vortex formation, shearing forces, and a precision job of turning solids into smoothness. Before we wrap, here are some practical tips to get the most out of your blender and keep it spinning like it should. Don't overload the jar. Too much material means the motor has to work harder, speed drops, you get a worse result. Use liquids to help create the swirl. A good blending job depends on circulation. If you're trying to use too little liquid, you'll get chunks stuck at the bottom. Use the correct speed setting. Start slow to pull things in, then increase speed for finishing. Avoid running high speed continuously for long periods if your blender isn't designed for that. The motor can overheat. Clean and maintain. The coupler, gasket and blade area should be kept clean and tight. Wobble or leakage steals efficiency. Match the machine to your job. If you're only making smoothies, you don't need a commercial-style 2000W monster. If you're crushing frozen blocks or doing nut butter, you do. By following these, you ensure that the high speed your blender is capable of actually translates into a smooth, efficient job, rather than wasted power or motor stress. So, why does a blender spin so fast? Because it needs to create the vortex, generate shear forces, pull and cut the ingredients, and deliver that smooth, consistent result. It's all about engineering, motor design, blade geometry, jar shape, power rating, working together. If you found this breakdown useful and you're curious about more kitchen tech deep dives, or want me to tear down another appliance, hit like, subscribe, and ring the notification bell so you don't miss the next video. And if you found something in this video that surprised you, share it with a friend who loves gadgets or kitchen gear. Thanks for watching, and I'll see you in the next one.